Today we're ripping apart RAG Retrieval Augmented Generation. Not the shiny, just add a vector DB version from your LinkedIn feed, but the cold, hard reality where your embeddings are garbage. Your retrieval pipeline is a latency nightmare, and your LLM is still confidently hallucinating about last year's financial reports. 3 experts, one who's battled RAG in production, one who translates AI hype into actual product, and 45 minutes of pure, unadulterated architectural truth. I'm Sam, and someone just asked me to implement RAG for all our internal documents without knowing what that means.
I built our first RAG system. It was supposed to be a game changer. Instead, it was a data scientist's fever dream. We thought just chunk text, embed it, search, and prompt. The reality was bad chunking, irrelevant retrievals, LLMs ignoring the context, and a bill for our vector database that made my CTO sweat. I learned the hard way that RAG isn't magic. It's a meticulously engineered system.
My job is taking these fancy AI models and making them useful. RAG sounded like the answer to every product manager's dream: accurate, up-to-date LLMs without retraining. But when the answers are stale, or the bot tells a customer their policy doesn't exist, that's a product failure. The challenge isn't just about knowing what RAG is, it's about making RAG work effectively for the business.
I've overseen countless RAG implementations. The pattern is clear. Those who understand the retrieval part as a complex system design problem, not just an ML problem, succeed. Those who think RAG is a button you press often fail. It's not about knowing what a vector database is. It's about knowing why yours might be underperforming or bankrupting you.
Dr. Martinez, you're our guide through this RAG hellscape. Anya and Leo, prepare to explain why garbage in, garbage out applies more to RAG than almost anything else in AI. No mercy, no hand-waving about semantic search.
Let's start simple. What's the fundamental illusion of RAG that developers and product managers fall for, and how has that illusion evolved over time?
Initially, the illusion was that it's a plug-and-play solution. You grab an LLM, point it at a vector database, and suddenly it's an expert. People assumed the retrieval part was trivial. As we evolved, the illusion became more subtle. Just use a better embedding model, or just use a fancy re-ranker. But the core problem of getting truly relevant context remains.
From a product perspective, the initial thought was it was a magic bullet for hallucination. Oh, RAG will fix that? No, RAG reduces hallucination by providing grounding, but if your grounding is irrelevant or outdated, you just get grounded hallucination. The evolution here is recognizing that RAG is an improvement mechanism, not a complete solution to model limitations.
Why do we need RAG at all, given large LLMs, and how has this justification evolved?
Cost, freshness, and control. Retraining or fine-tuning a large LLM is astronomically expensive and slow. Your knowledge base is dynamic. Financial reports, news articles, internal company policies, they change daily, hourly. Fine-tuning means your LLM is always out of date the moment it's deployed. RAG is designed for dynamic, external knowledge that changes frequently.
And control, with fine-tuning, the knowledge is baked into the model's weights. You can't easily audit why it said something. With RAG, theoretically, you can show the user the source document. That transparency is crucial for trust, especially in high-stakes applications. This justification has solidified as LLMs become more prevalent in enterprise settings.
Give me an example of a common RAG pitfall you've encountered that a constraint-driven approach could have avoided.
Poor chunking strategy. Everyone starts with split by paragraph or fixed token size. But what if a crucial piece of information is split across 2 paragraphs, or if a paragraph is too long for the LLM's context window? We had to analyze our document types. Legal docs needed specific section-based chunking, product manuals by feature, FAQs by question-answer pairs. Each document type was a unique constraint. Not defining these upfront leads to irrelevant or incomplete retrievals.
How do those chunking constraints affect the retrieval and generation?
If your chunks are too small, you lose context. The LLM gets a fragmented picture. Too large and you exceed context windows or introduce irrelevant noise. Then there's the needle in a haystack problem. If your relevant sentence is buried in a huge chunk, the retriever might miss it, or the LLM might ignore it even if retrieved. It's a constant balancing act between precision and recall, directly tied to chunk size and strategy.
And it impacts user experience. If a user asks about vacation policy, and the system retrieves the entire 50-page HR manual as one chunk, the LLM will either summarize poorly or just refer to the manual. The goal is to get the exact relevant policy snippet so the LLM can generate a precise, concise answer. Failing this is a critical product flaw.
What are other common RAG pitfalls every engineer should be wary of?
Underestimating data quality and preprocessing. People dump raw PDFs or scraped websites into a vector database and expect miracles. You need clean, structured data. Noise, inconsistencies, formatting issues, they all become garbage that poisons your embeddings and retrieval. Another big one is embedding space drift. If your data distribution changes over time, your old embeddings might become less effective.
Ignoring user intent and multi-turn conversations. A user asking, "What's our Q3 revenue?" needs a direct, factual answer. A user asking brainstorm marketing ideas for Q4 needs a creative, generative response. A single, naive RAG pipeline might not serve both well, leading to a fragmented, frustrating user experience. Also, not handling follow-up questions effectively is a common product pitfall.
Let's talk about hybrid search. Why is vector search alone insufficient?
Vector search is great for semantic similarity, but terrible for exact matches. If someone searches for invoice number 12,345 or a specific product SKU, embeddings might return semantically similar but factually wrong results. We learned to combine BM25 keyword search with vector similarity. The magic is in the blending strategy linear combination, learned weights, or query routing based on intent classification.
How do you handle multimodal documents with images, tables, and charts?
This is where RAG gets messy. Traditional embeddings only handle text. For images and documents, you need vision models to extract descriptions. Tables need structured parsing. OCR often mangles the data. Charts require understanding relationships, not just text. We've started using multimodal embeddings, but the tooling is still immature. Most companies just ignore non-text content, which means missing 30 to 40% of document value.
What about cost optimization? RAG can get expensive fast.
Caching is critical. Embedding calls for repeated queries, pre-computing embeddings for popular documents, and query result caching can cut costs by 70%. Also, query routing use cheaper, smaller models for simple factual retrieval and save the expensive models for complex reasoning. Don't use GPT-4 to find someone's phone number when a fine-tuned BERT can do it for 1/100th the cost.
How do you handle complex queries that need decomposition?
Real users ask things like compare our Q3 performance to competitors and suggest improvements. That's not one retrieval, it's 3 separate subqueries. You need orchestration logic to break complex questions into atomic retrievals, then synthesize the results. This is where agentic patterns emerge, the LLM planning its own retrieval strategy rather than following a fixed pipeline.
How is RAG evolving to address these challenges, and what are the promising future directions?
Multi-stage retrieval and re-ranking. Instead of one shot, systems are doing initial broad retrieval, then re-ranking retrieved documents, then potentially a second, more focused retrieval based on the initial LLM response or a rewritten query. There's also much more sophistication in query rewriting, where an LLM rewrites the user's ambiguous query to be more precise for the retriever.
An agentic RAG, where the LLM doesn't just answer, but decides if it needs to retrieve more information, ask clarifying questions, or even use tools beyond just retrieval, like calling an API or running a SQL query. It's moving from a passive retrieve and generate to an active reason and act system that truly understands the user's goal.
What about graph RAG and knowledge graphs?
Knowledge graphs capture relationships that vector embeddings miss. Who reports to whom, or which products depend on this component, requires structural understanding, not just semantic similarity. Graph RAG combines traditional vector search with graph traversal, but it's operationally complex. Maintaining graph consistency as documents change is a nightmare.
What about evaluation? How is RAG evaluation evolving beyond basic metrics?
Everyone measures LLM output with BLEU Rouge, which is useless for RAG. We're moving towards more nuanced metrics. You need to evaluate the retrieval component. Precision, recall, hit rate of relevant documents. Then you need to evaluate the generation component, factual consistency with retrieved documents, relevance, fluency, and faithfulness. And finally, end-to-end user satisfaction with human-in-the-loop feedback mechanisms that directly feed into system improvement.
The future of RAG evaluation must be grounded in business outcomes. Are customers getting accurate answers faster? Are support tickets being reduced? Is developer productivity increasing? These are the ultimate measures, and a good RAG system directly impacts them.
How do you detect when your RAG system is degrading over time?
Domain drift detection is crucial but under-discussed. Your embedding space shifts as new content gets added. Suddenly, medical documents are closer to legal documents than to other medical content because you added a bunch of health regulations. We monitor embedding cluster coherence and retrieval success rates over time. When they drop, it's re-embedding time.
What about adversarial testing? Can users break your RAG system?
Oh, they try. Injection attacks where users embed malicious instructions in queries, prompt jailbreaking to access restricted documents, and social engineering to extract information they shouldn't have access to. RAG systems need the same security mindset as any other production system: input validation, access controls, and audit logging.
How do context windows of 200K plus tokens change RAG strategies?
Larger context windows are a double-edged sword. You can stuff more documents into the prompt, reducing retrieval precision requirements. But longer contexts increase latency and costs exponentially. The question becomes, do you retrieve 20 small, precise chunks or 5 large, comprehensive documents? We're still figuring out the optimal strategy, but the fundamentals of good retrieval haven't changed.
Jesus Christ, so RAG isn't just about vector embeddings. It's about meticulous data pipelines, intelligent retrieval strategies, hybrid search, multimodal processing, cost optimization, and a deep understanding of how LLMs interact with external knowledge, all driven by practical operational and business constraints. This is way more than just add a vector DB.
Welcome to 2025. Anyone can use an LLM API, but designing a robust, evolving RAG system that delivers consistent, accurate, and cost-effective value. That's where the real engineering and product innovation lies.
This episode was brought to you by Engineer Panic, where we strip away the AI hype and show you the brutal, fascinating reality of building intelligent systems. Because understanding why your RAG system is still confidently wrong is probably important. We're back. Let's talk about the practical nightmare of actually succeeding with RAG. Anya, what's the most counterintuitive advice you'd give for building robust RAG?
Start with your retrieval, seriously. Spend 80% of your time on data cleaning, chunking, embedding quality, and designing your retrieval logic. If your retrieval is excellent, even a simpler LLM can give great answers. If your retrieval is bad, GPT-4 will still fail. It's a data problem at its core.
Ask why before how. Why do we need RAG? What specific problem are we solving? What are the acceptable error rates? What's the cost target? Don't just implement RAG because it's cool. Implement it because it solves a defined business problem with measurable outcomes.
And admit uncertainty. We'd need to test different chunking strategies, or I'd need to benchmark different embedding models for this domain shows mature judgment. Confidence without rigorous experimentation is how you build a hallucinating, expensive chatbot. Experimentation is key to RAG's evolution.
What about the biggest red flags you see in RAG implementations?
Obsession with a single metric, like embedding similarity. That doesn't guarantee relevance or factual accuracy for the LLM. You need a suite of metrics covering retrieval, generation, and human evaluation. Also, a lack of version control for your data and embedding models. Your knowledge base is constantly changing. You need to track those changes.
Ignoring the feedback loop, deploying RAG is just the beginning. How do you capture user feedback? How do you reindex documents? How do you refine your embedding space over time? It's a living system, not a static deployment. If you're not constantly improving it based on real-world usage, it will degrade.
And treating the vector database as a black box. Understanding how your data is indexed, how similarity is calculated, and the limitations of vector search is critical. It's not just a fancy key-value store for vectors. A deep understanding of the underlying search mechanisms is crucial for optimizing RAG.
What about handling regulatory and compliance requirements?
RAG in healthcare or finance is a completely different beast. HIPAA, SOX, GDPR, they all impact how you store, retrieve, and process documents. You need audit trails, data lineage, and the ability to prove exactly which documents influence which answers. Most RAG systems aren't built with compliance in mind, and retrofitting is painful.
What keeps you up at night about the current state of RAG development and education?
That it's still largely treated as an academic exercise or a quick demo. There's not enough emphasis on the gritty details of production RAG, data governance, robust update pipelines, handling multimodal data, and rigorous, systematic evaluation for real-world scenarios. The operational complexity is vastly underestimated.
The easy button mentality. People see cool DMOS and think RAG is a trivial add-on. It's conceptually simple, yes. But the operational complexity, the continuous need for data hygiene, and the nuanced understanding of how to make it useful for users, that's where the real challenge lies, and it's often overlooked in initial deployments.
That we're creating a generation of prompt engineers who can talk to LLMs but can't build the underlying systems that ground them in reality. The real innovation and value are in building the robust, scalable retrieval infrastructure that allows these systems to truly deliver on their promise.
How do you A/B test RAG improvements without breaking user trust?
Shadow testing and confidence scoring. Run new retrieval strategies in parallel, compare results offline, and only expose changes when confidence is high. For user-facing tests, start with non-critical queries and measure both accuracy and user satisfaction. Never A/B test with financial or health information. The stakes are too high.
Final advice for engineers who want to truly master RAG and contribute to its future.
Build real systems with real, messy data. Deploy something to production, handle real traffic, debug at 3 a.m. when your documents aren't indexed correctly. Nothing beats hands-on experience with the practical failures. The constraints and complexities become visceral. And learn information retrieval fundamentals. It's not just about ML.
Think like a business owner, not just an engineer. Every RAG decision has cost, risk, and opportunity implications. The best RAG systems understand that technology serves business goals, not the other way around. Focus on the impact, measure everything, and never stop iterating.
Master the retrieval part. Understand information retrieval, indexing, vector databases, and the nuances of semantic search and re-ranking. The LLM is the generation component, but the retrieval is where the significant engineering challenges and the future of RAG innovation lie. It's about how effectively you find the right knowledge.
This has been Engineer Panic. We've learned that RAG is a sophisticated engineering challenge, that its evolution is driven by addressing real-world pitfalls, and that its future lies in more intelligent, agentic, and robust retrieval systems. Sweet dreams, and may your embeddings always be semantically relevant.
Thanks for the reality check. Now, if you'll excuse me, I have to figure out why our RAG system is citing a recipe for brownies in response to a query about our Q3 earnings report.
And I need to explain to my CEO why we just spent $10,000 on vector embeddings for data we're not even using effectively. Also, why our simple document search now requires a PhD in information retrieval to maintain.
Keep building, keep thinking about the data, and keep questioning technology choices. The future belongs to engineers who understand that RAG is applied knowledge engineering, not just a simple LLM wrapper.
This has been Engineer Panic, where RAG meets architectural reality. Until next time, remember, your chatbot isn't stupid, your retrieval pipeline probably is, and the future is about fixing that with more than just better embeddings.